Hello, friends, students, and enthusiasts. Again, today I have come up with a new project. The name of the project is Automatic Door Lock System with Gas Leakage Detection and IR Remote Unit Unlocking. That is, you can unlock with the help of a remote because we are using an IR receiver. Okay, right. So only one IC has been used, that is LM358 operational amplifier. Again, this project is on operational amplifier. So please remember that. Okay. So very fast, what are the components we have used? LM358 operational amplifier, one gas sensor. Any of the gas sensor you can use, you can name it according to your gas sensor, the project name. TSOP is the 1738. TSOP 1738 is the receiver, IR receiver. BC558, two transistor, 547, one transistor regulator I've used, 5-volt regulator and one relay module and few resistors, breadboard and jumper wires. So these are the components. Now this is a very rough diagram I have shown here. That is the LM358, three transistors are there, two of them are PNP and one of them is NPN. So one transistor is used as a mediator between the LM358 and TSOP, that is 557. It is given in the bottom. Another transistor is a relay driver, as well as it will start the LED also. One more in the output of the relay, I have again used, instead of AC switching, I have used one more relay, that is 330 ohms, which is connected on the output side of the relay. Relay, again, it is driven by one of the transistor and another end is given to ground. Gas sensor output is given to pin number 3. Got it? And your TSOP output is given to pin number 5 from the emitter, that is of BC557, that is PNP transistor. Rest is all circuits are very simple. You can just have a look and you can do the circuits. So I will just tell you what are the step-by-step process, how it works. So a gas sensor detects leakage, first of all, that is if any gas or whatever the gas or any chemical it is there, it will detect it. Its analog output is fed into LM358 operational amplifier. I discussed that one end is going to the operational amplifier. When gas connection crosses the set threshold, the operational amplifier output goes high. Why? Because we have used a 10 kilo ohm variable resistor to set the threshold. Okay. The trigger then transistor drive circuit which analyze. That means the output will be given to the transistor and accordingly the relay will activate and it will lock the door. IR remote control I have used here, detecting signal from the IR remote. When the correct IR signal is received, the module output a low pulse. This pulse is processed by the transistor logic. Either it can be NPN or it can be PNP. So here I have used PNP transistor, which drive the relay to unlock the manually by remote control. So this is our project. So I've given you a little idea. Safety, where can you, in case of the gas leakage, the system unlocks or locks, both can be done. And manual IR, that is IR will unlock. This, it will be unlocking the system. So advantage of the application is safety during gas leakage, easy remote unlocking, low cost design with LM35 and transistor. Please remember, I told you in the beginning, for learners and beginners who want to study LM358 and want to do some new projects that is related to, which is very simple and this thing. So I have used two things here only with one IC. That is our project. Let's go to the lab and see the things around. In our lab, so I will just explain you about the circuit. But before explaining the circuit, I will tell you what are the important components. So this is my gas sensor MQ2. You can use any of the gas sensor depending upon your project. That is carbon monoxide or any LPG gas or butane or any other gas. So you get different type of gas sensors. So the output of the gas sensor are connected to the IC. This is my IC here. I will tell you, this is my LM358 IC. Only single IC I have used. Okay, this is my single IC I have used. Now, second important part. So this is my TSOP, that is IR sensor receiver. This one, TSOP sensor. Okay. So this works with the IR this thing. That means it will take IR signals. This is my relay, okay, for switching. And relay output, I have shown it given connection to this blue LED. There two LEDs I have also used here, two yellow color LEDs, one regulator. That is, this whole thing is circuit is working with 5 volt. Means switch, this is my switch, and I have given batteries. I've used two batteries. So let's see practically how it works. Suppose there is a gas leakage in a room, factory, kitchen, whatever it is. So suppose I'm just putting a gas, you watch it, what happens? And right. So two LEDs have come, that is blue and this thing. Now what I will do is, suppose the door is locked or this thing, gas leakage is this thing, and the gas has come down. The atmosphere is good, but even the door is locked. So at that time, what I will do is I will use this IR remote. Any IR remote can work. I will just put this IR remote here and I will just press the button. You can see I'm pressing the button here, and you can see the lock gets open again. Okay, the lock gets this is the indicator for the lock. Okay, that the lock gets open. Okay, so this is the process. So gas, again, watch it, gas, lock, okay, unlock, I will use this, okay? Unlock, I will use the remote, okay? So only by using one IC, how I'm operating the things, we can make so many ideas with this, you can make so many ideas. The idea is to give you an idea about the IC, that is operational amplifier, okay? Operational amplifier IC. And in this operational amplifier, we are talking about two comparators. All right. So one comparator connected to the gas sensor, another comparator is connected to this one. So both the comparators we have used it. I have used two transistors here. You can see one is this two transistor will drive these two LEDs. And sorry, the first one, it will drive this LED. The second transistor drives the relay. Okay. Or I'm given this thing, relay also connection to this and the relay output. These are the relay outputs. That is the secondary side. I have just for showing purpose, I have connected a blue LED over here. Okay. So few of the resistor I have used only 110 kilo ohm per preset. This is TSOP. TSOP, one end is ground, second end is supply, and third is the output. Third is the output, which is again going to one comparator. Pin number, that is, I have given it not directly to this, through this transistor, that is PNP transistor, PNP, okay, 558 transistor. I have given it to pin number 5 as an input here, this side, the other side of the comparator. Please remember, this has this side, you have this side of the IC, one comparator, that side of the IC, another comparator. So likewise, it has been used. 7.5, I have not given directly. I've used a regulator for that. Okay. This secondary side, I have used a negative supply, switching a negative. That means the center, I've given it to ground. Another end, I've given it to the LED. And the positive end, I've connected it through 330 ohms to supply. So likewise, this work, I will share the, you must have seen the complete circuit. It is there and you can do it. You can make changes. The only idea is to explain you about the operational amplifier.